Hello and welcome to Tech 24. Coming up, humanity is on the threshold of the Bionic Age, but are we ready for it? Professor Hugh Herr leads biomechatronics at the MIT. He'll tell us more about becoming cyborgs. And in Test 24, smarter, cleaner, and faster, startups are taking 3D printing to the next level. But first, how about some frankenfish for dinner? Genetically modified salmons have been cleared for human consumption in the US, raising some fear among consumers. Clément Bonneau has the story.
Hundreds of salmon eggs ready to hatch. But this is no ordinary salmon farm. In these tanks, dozens of genetically modified Atlantic salmon. 2 genes have been added to their DNA, including one that allows them to produce growth hormone. The aim to make these fish grow twice as fast as ordinary salmon. They reach adult size in 18 months instead of 36 in nature.
The early stages of production here are very, very similar. Where it starts to be different is that we take the fish at a time when they would usually be transferred into sea cages, and we continue the process in tanks with systems that clean and reuse the water.
Genetically modified salmon do not only grow faster, they also grow bigger while consuming 10% less food. AquaBounty has been selling these high-technology salmon in Canada since 2017, and the salmon will soon be available for purchase in the US starting in September 2020. It comes after the FDA lifted import restrictions earlier this year, a move cautiously welcomed by consumer groups who say GM salmon should be labelled as such.
Consumers aren't going to see the words GMO or GE, they will see BE or bioengineered instead. So the first thing consumers need to know is those are the same.
Potential health risks are another cause for concern among consumers. The state of California banned all genetically modified fish in 2004 due to inconclusive evidence.
There is no such thing as a disabled person, only disabled technologies. The author of this tagline is both the creator and user of bionic limbs. Hugh Herr leads the biomechatronics group at the MIT. So, how to build a bionic man? Well, we had the opportunity to ask him the question at the Unexpected Sources of Inspiration conference in Paris. Take a listen.
We study how the biological foot ankle works, and for example, how the muscles are controlled by the brain, and then we on computer chip, we program the computer chip to control the muscle-like motors in the same way that biological muscle is controlled by the spinal cord. So even though it's made of synthetic materials, the bionic limb moves as if it's made of flesh and bone.
And you actually saved the life of dozens of amputees with the Biome, the very first robotic prosthetic leg and limbs that actually behaves like a real foot and flush to blood type of foot, right? And now you're working on brain control bionic limbs. How does it work exactly?
We're actually in the surgical process when the limb is amputated. We actually configure the tissues to make them conducive for signaling between the nerve and the external computers and motors. So we create basically biological joints within the residuum and put sensors inside the body and collect information. So as the person thinks and moves these biological structures, we sense that, and that's communicated to the artificial limb. So a person can think, move the artificial limb, and also feel the movements of the synthetic limb as if the synthetic limb is part of their body.
Are we toward the end of disability?
We're not towards the end, but we're starting to glimpse this notion that technology can mitigate and sometimes completely eliminate disability. And I believe in this 21st century, we will eradicate human limitation and disability. So it's a wonderful use of science and technology in business to reduce so much pain and suffering.
Meaning that you probably also want to expand human capabilities for anyone else.
Yeah, I think that the exact same science and technology that will lead to the end of disability will also be the foundation for augmenting humans with technology, allowing humans to go beyond their innate physiology, allowing them to jump higher, run faster, think faster, feel things that they haven't felt.
So you're probably the very first citizen of a bionic society. What does it mean living at the Bionic Age? Can you drive us into this new era?
So we're used to just completely accepting our bodies from our genetics and what we were born with. And what it means to be bionics is that you can sculpt your own physicality, your own cognition, using design and technology. And you need not live with what you were born with. So this expansion of what the body can be is at the heart of the culture around bionics.
But now, some would also argue that there are downsides or potential downsides when it comes to human augmentation, and probably leading us to the creation of a two-tier type of society. What do you have to answer to this?
I think it's important that we as citizens demand that we own our own data and that we own our own bodies, and not allow governments and communities to take ownership over our bodies and our data. As long as we do that, as long as we strictly adhere to the idea of individual freedom and rights, I think we can develop augmentation technology and use it in a very productive way to reduce human limitation and suffering, and also to expand what humans can be. How we can be physically and cognitively, what we can feel, what we can experience. That's what bionics is about. It's this everlasting journey of expression, human expression, and expanding that expression in the world.
And you can watch it in full later on the interview on France 24, of course. And we're back on set with our in-house expert, Dan and Jake Holikar. Great to have you.
Thank you, Marjorie.
So ensuring effective control of prosthetic is also important. And in this regard, CNRS researchers have developed a new technique for controlling bionic arm.
Well, yes, Marjorie, these researchers performed experiments to harness the phantom limb movements in order to control a bionic arm. First of all, they identified and decoded the muscular activity that is associated with the phantom limb movements. They also analyzed the electrical signals that were associated with it. And all this data was then fed into a machine learning algorithm, which was trained to recognize these phantom limb movement activities. And in turn, it was linked to a prosthetic arm. And so this algorithm was able to direct the prosthetic arm to move in a way that phantom limb would move. Now, the important part about this experiment is that the researchers found out that the control of the prosthetic was more natural, it was easy, and it was intuitive. Of course, this experiment, as you can see, it was done with the prosthetic arm being placed next to the participant. It was not attached to the arm, so that's the next big step. So the researchers have found out that the participants were able to perform multiple maneuvers like picking up an object and putting it in the box as we see in this image.
Outstanding. And now there's another emerging field called cyborg botany. It's basically the convergence of electronics, robotics, and plants. One of its examples is Elo1.
Well, yes, Elo1 is a cybernetic plant that is attached to a robot with wheels. Now, plants communicate internally by sending bioelectrical signals in response to changes in temperature, in sunlight, and moisture. So the team from MIT, they inserted silver electrodes in the stems, in the leaves, and the soil. And these electrodes essentially amplified these bioelectrical signals, which were then passed on to the robot. So the robot was moved, or its movement was determined by these natural bioelectrical signals. Now, if you watch the video, you'll see that this robot moves towards the source of light. So the moment the light is turned on, it moves towards the lamp. So this is one example of cyborg botany.
And still on bionic plants, a team of researchers have mimicked the process of photosynthesis and, in a sense, reverse combustion. So can you tell us more about this bionic leaf?
Well, this bionic leaf essentially consists of a photovoltaic cell that generates electricity. And when this leaf is placed in water, the electricity splits water into hydrogen and oxygen. So hydrogen itself can be used as a fuel. But this hydrogen is then made to act with engineered microbes and carbon dioxide to produce alcohol-based fuels like isopropanol and isobutanol. So yeah, this is an example of reversal of combustion.
Thank you so much, Bionic Dan. And now let's move on to Test 24. And now let's take 3D printing to the next level. Dan, what do you have in store for us today?
Well, we have the 3D printer called Magis, which is developed by the French startup Dagoma. This startup is based in Roubaix. This printer is very simple, it's very easy to use, and most importantly, it is eco-friendly. The reason being that it uses vegetable fibers instead of plastic. And here's a little creation I did in the morning. So this is biodegradable.
Congratulations on your creation.
Thank you very much. So that's very important. Secondly, its ease of use stems from the fact that you can 3D print different objects. Like here, this was printed on the Magis printer. It's the nozzle of a vacuum cleaner. So all you have to do is you have to go on one of the many 3D printer websites. There you get a file, you download it on this card, and you just insert this card in the 3D printer, and it will start printing the object. Now, the other thing is that you can print the object in 2 different colors, and you can also use 2 different filaments.
And speaking of going green, let's take a look at this amazing 3D printer that can create a reef out of concrete.
Well, yes, this is the product of another French startup called X3, which is based in Rungis, and they specialize in 3D printed objects made of concrete, ranging from the reefs, as you mentioned, from houses. So they are currently involved in a project for building houses in the east of France. And as far as the reefs are concerned, these reefs, I'll just show you a sample of it. But the reefs that have been lowered in the sea in the south of France are much bigger. They have a dimension of 1 meter by 2.5 meters, and they are very intricately designed, mimicking how the natural coral reefs appear. So the idea is that because of the destruction of the natural reefs, this could be a good replacement, and they are hoping that this would encourage or rather this could turn out to be the habitat for aquatic life.
Thank you so much for the explanation, Dan. And that's all we have time for, but do stay in touch with us with the hashtag Tech24 on social media. Thanks for watching. We'll be back soon.